let's do the 12.2 self quiz. So sketch your angle, then find its referencing. So 220. So let's sketch 220 real quick. Here's 0. Here's 90. Here's 180. Here's 270. And maybe 360 and go around. Now remember, all I care about is in the right quadrant. So 220 should be between 180 and 270. So in the third quadrant. So somewhere right here should be 220. So that angle there would be about 220. I want the reference angle. Now again, some people give me this thing. That is wrong. You want the acute angle between the two guys. So right there. So is this 220? 220 minus 180. Give me 40 degrees. So right there. 7 pi over 6. Now again, reference angle part is super easy. Reference angle is just 30 degrees. Anytime it's over 6, it's 30 degrees. You want to treat it like it's pi over 1/8. Pi over 6, which is the same thing as saying, like, it's equivalent of saying, not the same, but equivalent of saying 180 over 6, which will get you 30 degrees. Right, so reference angle is easy. Over 6, automatically 30. Now let's draw, we have to draw the angle. So here's 0, here is pi. That's all we really care about. And now, so where's 7 pi over 6 at? So common denominator, 6 over 6, right? Pi is the name is 1 pi, which is the name is 6 over 6, 1 pi. 7 pi over 6 means we would go a little bit past that. So around here is 7 pi over 6. So that's the angle we're finding there. Find a positive coterminal angle of each thing. So positive coterminal angle. So remember, that means we're going to add 360. So plus 360, and I get 580. Over here, there's no 360, it's in radians, so 2 pi. Same as 360. Put over 1, common denominator, 6 over 6. So I get 7 pi over 6 plus 12 pi over 6, which gets me 19 pi over 6. There we go. Convert 96 degrees to radians. So 96 degrees. I'm going to times it by pi over 180 because I want to convert to radians, so I want the pi. And that, probably just use a calculator because that's going to be a decimal. 96 times pi. And I'm feeling we have to use like the answer for the next question. So let's do it, get out of the way now. And I get 1.68 roughly, approximately. Next one. Shanna is about to perform a relay handoff on a crucial on a circular track that has a radius of 20 meters, and her track partner Katie is standing 96 degrees away from her. How many meters does Shanna need to run to pass the baton to Katie? So here's her track, right? So here's Shanna, and then here's Katie. And I figure out how far she has to run to get that. So that's what we're looking for, the arc length. An arc length, remember the arc length formula? Not sure, I give it to you right here, right below. That formula is L equals R theta. Now keep in mind, if I'm using this formula, theta has to be in radians. So that's the biggest thing here. This is not in radians, so I can convert that. So I can convert 96 degrees to radians. And luckily we did that already. 96 times pi over 180. We did it up here, and got about 1.68. So that's my theta. My radius doesn't say in the picture, but it says in the problem 20 meters. It says 20 meters. So, and again, it's application problem, so I do want an answer to this. So I'm going to get my answer and multiply that by 20. So 33.5-ish. Approximately 33.5 meters just to run. And that's the self-quiz.